Let me know if I'm audible. Hey, what's up, guys? Let me know if I'm audible. Let me know if I'm audible. बोल दो अगर ऑडिबल हूँ तो फिर मुझे आइडिया लग जाएगा. Let me know if I'm audible. Cool. Let everyone join in. Cool. So any doubt? Yeah, any doubt from yesterday's class? If you have any doubt whatsoever from yesterday's class, do let me know. Do let me know if you have any doubt from yesterday's class. Yes, final lecture today. Yes. You can use STL. You can definitely use STL. Cool. So let me just quickly give an introduction till everyone joins in. So the introduction is basically today will be lecture 3. As you know, in lecture 1 we did study about containers, struct, about the use of namespace and all that stuffs. In lecture 2 we did learn about all the containers that are widely used in programming, in computer programming, in data structure algorithms, in interviews. And in lecture 3, as I said, today we will be learning one container that is left, which is again a very important container which is very widely used in comparative programming, that is the Bitset container. And this other thing that we will be learning is the algorithms. Yes, the algorithms like lower bound, upper bound, binary search, min element, max element. We're going to learn about everything today. And right after that I'll be teaching you comparators. Yes, that will be the last part of today's lecture. Comparators, basically when you sort something, you sort it according to ascending or something like that. So how can you actually make it sorted according to descending or according to your use case? So we will be discussing couple of examples, or 3 or 4 examples. That is today's agenda. STL algorithms is used. Yes. STL algorithm is definitely used today. Cool. So अभी जाते हैं introduction के लिए. So for all the people who are joining in new, my name is Raj Vikramaditya. I'm generally known as Striver in the programming community. I'm a competitive programmer. Currently, I'm working as a software engineer at Media.net Director. Prior to this, I was working at Amazon. I'm a candidate master at Codeforces. I'm also a 6-star at CodeChef. I have a couple of years of teaching experience, and I also run a YouTube channel which has around 90,000 subscribers. The subjects that I'll be taking over here and at Unacademy are competitive programming, data structure algorithms, C++, interview preparation. So I'll be just going through all the new batches that have started on Unacademy. There are 3 batches that have started on 6th of July, and the first batch is Mahayodha, which is a 2-month master course on advanced programming topics. So for someone who's looking for an advanced kind of a course, he can definitely join this. It's a 2 months duration course. The next one is the Eclavio 2.0, completely based on Java. Starts from beginner, goes to intermediate, then takes a journey throughout to the advanced. Again, 8 months course. Then the third one is the Brahmastra 2.0, which is the exclusive 5-month learning track for college and off-campus placement. This goes live. This has gone live rather on 6th of July, and it's a 5 months duration course. So in order to get access to all these courses, you can definitely vouch for the plus subscription benefits. If you take that, you'll get India's best programmers, as well as all the interactive live classes. Just like this, you'll get a better live version over there, and also you'll get dedicated doubt support after the live classes are over. Once all these are over, you'll also be given a set of practice problems which are handpicked by the educators themselves. So you get everything under the subscription. And yes, if you take up the subscription, you get access to all the current live lectures of any of the instructors, as well as all the previous courses that have been completed. So that is, yes, a lot of people were asking me when will my course come. The date is around 26th of this month when my batch will start. So obviously you can check that out too. So again, the last thing before starting, if you're new to this channel, make sure you like the stream and subscribe ka button, to make sure you click it, and also press the bell icon, because probably the next day that I'll be teaching is a recursion, the advanced version. So just in case you get to know ki when will I be teaching, so bell icon is very very important. So without actually wasting any time, let's get started for day 3. Okay, course will be going live on, my course will be going live on 26th. Yes, the announcement from the official announcement will come in, but I just made a note, I just had a talk with the team. They said me it will be on 26th. Yes, it will be completely on competitive programming and specifically targeted for all the coding rounds of every company. That is what I'll target. Okay, day 3. You can follow me, the educator profile is on the description. You can follow me over there to catch up all the updates. Cool. So Bitset, how many of you are aware of Bitset? Before getting into Bitset, do you know a data type like integer takes up 16 bits, a data type of character takes up 8 bits, and that is why when you declare an array size, that's when we declare an array size of 100, the space taken by this is actually way more than a character array takes, because every index is storing an integer which is essentially of 16 bits, and when you talk about character, it's essentially of 8 bits. But do you know something as Bitset? Yes, Bitset tends to take up 1 bit. Bitset tends to take up 1 bit. Yes, it just takes up 1 bit, which is 8 times lesser than the smallest possible character. Yes, that's the smallest possible. If you do not consider Bitset takes up 1 bit. So if you declare something like Bitset, this is how you define the container. Bitset of BT. Again, this is the declaration. So you're basically saying I'm declaring 10 places with the variable name as BT. You can keep this variable name as whatever you wish to. You can keep it as a whatever you wish to. ठीक है? क्या question पूछ रहे हो? I didn't get that. Okay, so basically what this does is this creates an array kind of structure. Okay, this creates an array kind of a structure which again of like 0 1 2 3 and so on till 9. The indexing is like this in the Bitset. The indexing is like this in the Bitset. Got it? That is how the Bitset works. This can be anything like 1000, 10,000. It can be anything. Yes, there is a certain boundary. It can only be up to 10 to the power 8 or near about that, because as I said, Bitset takes up 1 bit. So whenever you're defining a Bitset of 10 BT, that is way faster than defining an integer A of 10. Remember this. Sorry, the space taken is way lesser than an integer array. So that's the advantage that the Bitset gives up. Where is this Bitset generally used? Generally you'll find this Bitset being used in a lot of segment tree problems. Yes, I'll be teaching that in future, but yeah, Bitset is generally used in a lot of segment tree problems. When you store elements in the node of the segment tree, we tend to use Bitset, because Bitset takes up very small space. So whenever you go in your future, make sure you check out segment tree with the help of Bitset, not now. Cool. So let's move forward. What are the functions? Kya question aa raha hai? What is data type of this? Again, it can be Bitset of int, it can be Bitset of character, it can be Bitset of double, it can be Bitset of anything that you wish to. Got it? It can be anything. Cool. So there are a couple of functions. So you can definitely do it something like this. You can definitely do it scene of bit, and in the machine, when you're giving an input, you can give a 10 size. Let's keep it 5 so that we can easily do it. You can give a 5 size 1 0 1 0 1. This is possible. If you give this goes into the BT of the 5 size. 1 0 1 0 1 goes into the BT of the 5 size. That is what happens. Okay, you can definitely do this. Or the other way is you can say bt.set. So I'll talk you through the functions. There is all, there is any, there is count function, there is flip function, there is a lot of function. None, there is set, there is reset, and then there is size. There's a lot of functions, by the way. Size, and there's one more test. So let's talk about all these functions. So these are the functions that your bitset container generally provides to you. Okay, these are the container. No, bitset is not a data type. It's a container. It's a container. It's not a data type. It's a container. Okay. Okay, so how does this store in? Yes, it does store. Memory allocation is always continuous. Okay, what does this means? What does this means? Assume you have given something like this 1 1 1 1 1, which means all the 5 bits are set. So if you do bt of all, this returns a true false, this returns a true or a false. Remember this. On what basis? If all the bits are set, it returns a true. If any of the one bit is unset, it will return a false. Like in this example, 1 1 1 1, all the 5 are set, so this is going to print as a true. This will print a true. But if I just make a single 0, this will print false. So all means if all are set, print true. If anyone is unset, print a false. All. Got it? So that's the definition of the bit set of all. That is the way you can check if all the positions are filled with 1 and 0. Yes, I forgot to tell you one thing. Bit set only stores 1 or 0. It only stores 1 or 0. Like you cannot store a number. You cannot store a number like 5. It only stores 1 or 0. Got it? Let's come to the next function, that is any. Right? We can come to any. What is any? So if I do bt of any, okay, if I do bt of any, I'll tell you what will be the output. If bt is something like 1 0 0 0 0, then this will print true. Any means if any of the one bit, any means if any of the one bit is set, I print a true. Like any, कोई भी एक set है तो I'll print a true. What if I just do it something like this? Then this will print a false because none of the bits are set, so it's gonna print a false. Remember this. There can be multiple bits set, that is okay. This is also okay. It will give you a true. If any single, at a minimum, if one bit is set, it will return you what? False. Sorry, true. Got it? Now what about count? As the name suggests, it's very simple. If you just do a cout of bt.count, this is going to print the number of set bits. What is set? The number of ones. The number of ones. For an example, for bt, which is something like this, 1 0 1 0 0, bt.count prints 2 because the number of set bits, the number of set bit is 1, is 2. Got it? True for all 1 and all 0. Can you just elaborate? Yeah, Hitesh has answered that. Let's come to flip. So assume you wanna flip. Yes, assume you wanna flip. So what you can do is you can set bt.flip the position. You can say bt.flip the position. So the second index for an example, your bt is something like this, 1 0 1 0 0, and you say second index. So the second index is this. This is the second index, correct? So what will happen is the bt will become, it will flip that 1 0 0 0 0. So 1 becomes 0, 0 becomes 1. Flip means 1 becomes 0, 0 becomes 1s on that particular index. That's how flip works. Let's come to the next operation. None means कोई भी set नहीं होगा तो true देगा. If none is set, then true, else false. So for a bt which is like none is set, let's assume. So if you do a bt dot none, this is going to return a false. Why? Because someone is set. But for a bt which is something like 0 0 0, then if you do a cout of bt dot none, this is going to present of true because None is set. None is set. That's why it's gonna present you with something as true. Got it, everyone? Yes, yes. Has everyone got it? I'll tell you how to know if a bit is set or not. I'll tell you. I'll come to. There are a lot of functions remaining. Okay. So that is how you've done it. Now what if I want to set some bit, set some particular bit. I want to make sure it sets. So for set, there is couple of options. If you want to set the entire range, you can just call bt.set. If you say bt.set, the entire 5 positions will fill up with 1 1 1 1, irrespective of what it has. It'll get entirely as 1 1 1 1. That is what will happen with bt. It gets entirely as 1 1 1 1 1. Got it? That's how bt.set works. There is another property of bt.set. If you just give the position, sets the second index. Doesn't matter if it has a 0, doesn't matter if it has a 1. It goes and sets the second index. Got it? There is one more position. If you want to say, hey, go and set the second position as 0. Like if you're just giving set as 2, it will go and set it as 1. But if you specifically want to set it as like 0, then you have to pass the 0 with it. So if you pass the 0, then it will go and set that second index to 0. Got it? Reset is the exact opposite of set. If you do a bt.reset, this will turn all indexes to 0. Again, reset, if you do a 2, turn the second index to 0. Got it? That's about that stuff. Now, if you want to get the size of your bitset, so if you just do bt.size, it will give you 5, because initially you declared a bt of size 5. That's how you can do a bt. Now what about test? Now assume you wanna find if a particular index is set or not. You will say bt.test 1. So at a index 1, checks if the bit is set or not at index 1. That's how the bt.test works. That's how the bt.text works. How to flip all the bits, I've told you ना. ये तो रहा flip. अगर flip को ऐसे लिख दोगे, 2 हटा दोगे तो सारा flip हो जाएगा. I told you ना, if you just wanna flip it, just write bt.flip, that will flip automatically. Cool. Line 632, sure. Dot set, you're saying go to the second index. Doesn't matter what is at the second index, just make it 1. You go and make it 1. That is the meaning of set. Correct? Any other questions? You can definitely tell me if there are any other doubts. Please tell me if there are any other doubts. Has everyone got it? Has everyone got this? All the entire BT concept? Has everyone got the entire BT concept? I'll keep it at 1 flip. Has everyone got the entire BT concept? I'll keep it as 1 frame. 634. Okay. BT.set. So I'm saying go to the second index and set it with 0. 2, 0 means go and set it with 0, not with 1. I'm passing what to set. Alright. Okay, you can bring in with doubts. If there is any doubt, you can definitely bring it. Can I get a yes if everyone has got the bitset container? No, reset doesn't have that option. Reset means reset it to 0. Reset 2, 0 is not possible. Explain any. Any means क्या कोई set है? पूरे दुनिया पूरे उस 5 बक्से में क्या कोई 1 है? Any क्या कोई 1 है? अगर है तो true बोल लूंगा, नहीं तो false. Got it? Arnab, Kujashi, Arnab. Reset 2, 0 is not there. Only set has an option of that. Reset doesn't gives you an option of 2, 0. Reset only has couple of ways. Set has 2 ways. Okay? The use is at segment trees. Obviously, you people are very beginners. I cannot teach you segment trees. We generally use them in segment trees while we use in the nodes of the segment tree, because the memory allocation, the memory that it takes is very less. So I generally use it in segment trees. Also, if there's a question which is related to 1 and zeros, you can definitely use this instead of using an array. ठीक है? सबको आ गया पूरा? yes फटाफट लिख दो. Size and count. Count tells you the number of ones, where size tells you कितने bits है, total कितने bits है. Size tells you the number of bits, where count tells you कितने 1 है, उस सारे bits में कितने 1 है. Got it? Yes, test returns a bull value. कल दे दिया था, डाल दिया. Okay, any other questions? Like it becomes very tough for me to answer such a huge crowd. 118 लोग live है and there's already a 15-second lag जो ये Unacademy Plus पे usually होता नहीं है, मतलब ये YouTube पे बोल के हो रहा है. So थोड़ा सा crowd भी ज़्यादा है, तो थोड़ा अगर आपका आंसर नहीं क्वेश्चन तो बार बार पूछ लिया करो. Someone will answer it. Yes, the size specification is important. ठीक है, आगे बढ़े algorithms पे. Has everyone got it so that I can move to algorithms now? If everyone has got this, I'll move to algorithms. I need a yes from everyone. And you haven't liked the stream yet, yaar. You haven't liked the stream. This is very bad. No one has liked the stream. Bitset is of any data type. How to increase or decrease bitset? No, there is no resize option, man. There is no resize option. Sorry. There is definitely no resize option, so you cannot do that. There is no resize option, so you cannot do that. Any other questions? Any other questions? I'll take that for the next 1 minute and then I'll start off with that. Cool. Looks like no question. ठीक है, शुरू करते हैं. ओके, बाय द वे यहाँ पे मैंने इंट डिक्लेयर तो नहीं किया ना कि बिट 5 साइज का है. 1 और 0 ही सेट कर सकते हो और कुछ सेट नहीं होगा. यू कैन जस्ट सेट 1 और 0 मैन. यू कैन नॉट सेट एनीथिंग एल्स. यू कैन ओनली सेट 1 एंड 0. ठीक है, सिर्फ 1 एंड 0 आप सेट कर सकते हो, आप कुछ नहीं सेट कर सकते. बिट मतलब 1 और 0 ही होता है. व्हेन आई टॉक अबाउट बिट बाइनरीज इट्स 1 एंड 0. ओके, कूल. लेट्स मूव टू द फर्स्ट एल्गोरिथम. Start off with algorithms, which is question for bits. क्वेश्चन कराएंगे, लो बाउंड अपर बाउंड का कराएंगे. बिटसेट का देखो मैं आपको क्वेश्चन करा सकता हूँ, सेगमेंट्री. उसके लिए मुझे पूरा सेगमेंट्री पढ़ाना पड़ेगा, समझ रहे हो ना, तो काफी दिक्कत हो जाता है. समथिंग लाइक लो बाउंड अपर बाउंड बाइनरी सर्च, आई कैन डू दैट क्वेश्चन फॉर यू बिकॉज इट्स मोर स्पेसिफिकली, समझ रहे हो ना कि वो क्या है. That's mostly array kind of questions. You can understand array kind of questions, but the other containers are generally used in tougher level of problems. So I cannot teach tougher level of problems as of now, right? So algorithms. Let's come to the first algorithm, which is sorting. So generally, what kind of containers did we learn where we can store in linear fashion? One was array, the other one was vector. I think this was the couple of containers that we did see where we can actually store elements in a linear sequential fashion. So sort, if you just write, let's assume you have declared an array of size n, and this n has been user inputted. This n has been taken by the user. So you have to just write array, comma, array plus n. So if you just write this, whatever is your array, if you have taken this from user, whatever is your array, remember this, whatever is your array, it automatically sorts your array in increasing order. In increasing order, it will automatically sort your array. This is how you write sort. What if it's a vector? Assume I declare a vector of size vec 5 size and the 0, and probably I can take the inputs. What if a vector is something like this? I've taken all the inputs. Now, in order to sort the vector, you have to write the first iterator and you have to write the last iterator. Like, it means, again, the similar concept. Remember this concept. So it means it starts sorting from the first iterator and then it sorts till the end iterator. And this sort doesn't use merge sort. It uses 3 kinds of sort in the backend. Yes, it uses 3 kinds of sort. You can again Google that and learn about that, but not required. If in an interview someone does ask you, how have you implemented this sort? You just tell them, I can use the C++ STL or a Java collection for an example. And in the backend, if you want me to implement a sort algorithm by myself, I'll implement a merge sort. Do not implement the backend algorithm of sort. It's very, very complex and I don't want you to do that. Just know merge sort, right? And if in an interview someone does ask you to write sort instead of using this, you can definitely write the sort of merge sort. समझ में आ गया? ठीक है. See, Xavi, there is no use of all the functions. If they are providing you with functions, you just take it. That is it. There is no use of functions. Okay, cool. So that's how you sort it. So basically, assume that you're given a vector. Let's assume you're given a vector which looks something like 1 comma 6 comma 2 comma 7 comma 8. That is how, or you can say 7 comma 4. This is how your vector looks. Okay, and I want you to sort it so that only indexes from 1 to 3, that means this index, 1 to 3 means this index. If you remember, do you know the indexing? This is the 0th index, this is the 1 index, this is the 2 index, this is the 3 index, this is the 4th index. I want you to sort only 1 to 3 index. So I want you to have the final vector after sorting as 1 2 6 7 2 6 7 and then a 4. So basically this 6 to 7 is what I want to sort. I just want to sort the middle junction. I don't want you to sort anything beyond that. I just want you to sort the middle junction. So how will you do that? Array and vector का difference बता चुका हूँ, already बता चुका हूँ. Dynamic है vector, array is static. Like array has to be given a static size. Okay, so how to do that? Can you tell me how will you do this? Merge sort is the efficient complexity which uses n log n. Remember, this sort takes a time n log n. The sort takes a time n log n. Okay. How will you do this? Can you tell me how will you do this? Can everyone answer me? कैसे करोगे? Well, I'm waiting for answers. थोड़ा lag है. Perfect. Trishul is perfect. Perfect. So I'm saying you have to sort from this. So what is this iterator? Can I say this iterator is nothing but begin plus 1. So sort of vector dot begin plus 1 vector dot begin plus 4, because I want to sort till the 3rd index. So if I just want till 3rd index, if I write 4, that means it will automatically make sure that it takes 1 and it doesn't take 4, that is this bracket. Got it? Has everyone got that? Perfect. मर्ज शॉट, क्विक शॉट और एक शॉट है जिसका कॉम्बिनेशन लगता है. इट्स समथिंग नोन एज क्या, ट्रिक्स, कुछ ऐसा नाम था, मैं भूल गया नाम. जरूरत नहीं होता तो याद भी नहीं है मेरे को. yes. I need first index, that is why plus 1. Plus 1 means go ahead one step. Iterator. Begin means this index. Plus 1 means go ahead one step. Plus 2 means go ahead 2 steps. Begin. Plus 3 means go ahead 3 steps. Plus 4 means go ahead 4 steps. Got it? Perfect. I think everyone has got it. You can also write it as vec.end minus 1 synonyma, but since I specifically mentioned from 1 to 3, you're not aware na, that 3 is the minus 1th index. That is why you always write it as plus of something. Got it? Perfect. Okay, so similarly, you can also write in array. If they ask you in array to sort, from 1 to 3, you can also write it in array like sort. Array is the 0th index, so you can say plus 1 array of plus 3. This is also applicable in arrays. This is also applicable in vectors. In vectors, the begin stuff comes and there is an end stuff. Again, you can also sort this in descending order. For that, you will be requiring in comparator, but the comparator stuff will teach you at the end. Okay, so sorting is clear. क्विक सॉर्ट, हीप सॉर्ट ऐसे कुछ होता है. इंसर्शन शॉर्ट नाम से मुझे नाम भी याद नहीं है, फर्क, इसलिए देख लेना, गूगल कर लेना. ओके, कूल. सो इज द सॉर्टिंग एल्गोरिथम क्लियर? So if you can tell me if it is clear, then I'll move across. Just give me a yes so that I can move across. Okay, cool. हाँ इंट्रो शॉट कहते हैं, इंट्रो शॉट कहते हैं, सही बोला, इंट्रो शॉट कहते हैं। अब मुझे याद है। ठीक है। मूव करें आगे, आगे मूव करें। Shall I move ahead? Shall I move ahead? Okay, cool. Let's move to the next algo. That is reverse. If I want to reverse, again the same concept. You write reverse, and in back you write array plus 1, array plus n. It automatically makes sure that it reverses. So similar to merge. You write reverse, start iterator, end iterator. If you just give this, it automatically reverses everything in between start and excluding the end. Excluding again follows the same method. This and this. So this is how you can reverse in vectors. It will be vec dot begin, vec dot end. If you want to reverse from first to the third index, it will be vec dot begin plus 1, vec dot begin plus 4. So this will make sure that the elements are reversed. This will make sure that the elements are reversed from the first, excluding the end iterator. Clear है? दोनों केस में इंक्लूजन तो आ रहा है, प्लस एन लिए ना, तो एन मतलब लास्ट इंडेक्स इन एरे इज एन माइनस 1 इफ यू रिमेंबर. लास्ट इंडेक्स इन ओके यहाँ प्लस 4 होगा, सॉरी इन प्लस 4 होगा, एक्सट्रीमली सॉरी ओवर हियर दैट देयर विल बी प्लस 4. Thank you Sonima, thank you. That will be plus 4. Okay, cool. So vec dot begin plus 4. Perfect. And in arrays, it'll be the same thing. Reverse array plus 1, array plus 4. The same thing. You have to just give reverse and this. Got it, everyone? Cool. Now, welcome to the next. ये बहुत सिंपल था, आगे बढ़ते हैं. If I want to find the maximum element in any index range. So generally if I want to find from any index i to j, give me the maximum. So generally this is how you do it, right? Int k equal to I, k lesser than equal to j, k plus plus, and what you do is you keep a maximum element as probably, let's say, int mean. Everyone should know this. A very simple stuff. And what you do is, if your array element of k greater than maximum, you say maxi, you become array of k. That's how you find in normal. In order to find I to j, this is how you find the maximum. Correct? ऐसे करते हो ना? Right? Now, there is essentially an algorithm which does this for you. Yes, there is essentially an algorithm which does this for you in super quick succession, and that is something like this. If you need the element that is maximum, you give a star pointer, you write max, you write element, and you say array, comma, array plus n, again first comma last iterator. If you give max underscore element, this, if you do not give star, if you do not give star, this will return you an iterator. Remember this. This returns you an iterator. So if you remember, in order to get the element at that position, you have to give a star. So if you give a star, the max element is automatically found out. Again, the internal implementation is this. This is the starting pointer plus 0. This is the ending pointer n. So that is how it is implemented, right? Cool. And in order to get the minimum element, again, it's the opposite of that. Min element array comma array plus n. Again, if you want to do the same thing in vectors, I'll just copy paste. If you want to do the same thing in vectors, just write vector dot begin. Just write vector dot end. That'll make sure that it finds in that index the minimum and maximum. So from the next day, if someone tells you, hey, give me the minimum and maximum in this range, I think you know how to do that. You have to just give you a star, and you just say first iterator, again same and you say the last iterator. That's it. Since I've explained you first and last iterator, I'll not be explaining you again. Clear hai? Clear hai? Perfect, perfect. Clear hai? Is that clear to everyone? Is that clear to everyone? Get me? Yes. If max element, min element is clear, then I'll move to accumulate, count, find rather. Clear? A yes from everyone will help. Yes from everyone will help. Okay. Now what if I give you a range and I want you to find the sum in that range? Like for example, I give you a range I to j, tell me the sum in that range I to j. So how do you do that? The basic implementation is very simple. You give a variable sum and then you pass on int k equal to I, and then you loop in the array till j, then you do a k plus plus, right? And you say sum plus equal to array of k. That's how you do it, right? That's how you do it, right? अरे भाई टच टाइप करके क्या कर लो बाद में. Okay, so how do you get the sum? Like if you see this line of code, it gives you the sum between the index I until the index j. It gives you the sum between the index I until the index j. So if for a particular index to a particular index you require the sum, how do you get this sum? That's my question. So very simple, very simple. If you just write accumulate, from the first iterator, so that's an array plus n is your last iterator, and you initially give a sum 0. This is the initial sum. Whatever initial sum you have given, it will be added to the sum in between this range. Like if I keep sum equal to 10 and I want all the elements between I and j to get added to this 10, it will be added to the 10. So you can also give here 10. This is the initial sum. This is the initial sum that you'll be given. So basically, if I talk about the syntax, again it's the same thing. Accumulate. This is the start pointer or iterator, whatever you can call. A lot of people are saying me to call it pointer, but yeah, doesn't matter. End iterator, pointer again, and the initial sum that you want to carry. The initial sum that you're gonna carry, right? No second and third element का कोई trick नहीं है. You have to just normally do it. If you want to use C++ STL to find second or third maximum, just sort it, and after that the back elements will be your second maximum, right? Sort कर लो, हो जाएगा. सॉर्ट कर सकते हो या फिर नॉर्मल इंप्लीमेंटेशन करोगे तो 2 वेरिएबल लगेगा, ठीक है. Perfect. So in case you want the sum in a vector, again you can do the same thing. In case you want a sum in the vector, right? What will you do? You'll just do this stuff, right? Vec.begin. Hey, spam mat karo, bro. Spam mat karo. There's no point in spamming, bro. Spam क्यों करो? पढ़ने और पढ़ाई करो. Cool. Does this accumulate works in case of difference also? Difference in the sense? Can you tell me what do you mean by difference? Yes, you can use these functions. See, just tell the interviewer that this function does that. Generally, the interviewer will not ask you to implement, but if he asks you to implement, you can implement, right? This is not a big deal to implement. You can definitely implement that. For something like a set or something like other algorithms, they will not ask you, but something like max element, binary search, they might ask you to implement, okay? वही तो स्पैम क्यों करना है, पढ़ना है, पढ़ाई करो. ठीक है, चलो accumulate आपको समझ में आ गया. अभी हम आते हैं what if I give you an array like this, which is something like 1, 6, 7, 1, 2, 1, 3. Okay, and I give you an element x equal to 1, and I have to tell me how many times the element 1 occurs in the array. I want you to tell me how many times the element 1 occurs in the array. You'll be like, okay, fine, that's a very simple step. I'll keep a counter variable as 0, and then I'll do for int I equal to 0, I lesser than n, I plus plus, and I can say if array of I is equivalent to x, then I can do a counter plus plus, right? And then I can print the count. Can I say this is how you can easily count how many times the x is present in the array? Can I say this is how you can easily count how many times the x is present in the array, right? Correct. So how can you do that? For this, there exists a count function again. So you can say count first iterator last iterator x. So if we just give the first iterator, last iterator, and x, this will give you easily the count instead of writing. So array plus n, and you give the variable x1, that is whatever is the variable you give it, it will automatically find you the count. And remember, all of these are one liners, but the complexity taken is similar to the implementation. The complexity will be big O of n. This loop is running for n times, hence the complexity will be big O of n. Hence the complexity will be big O of n. Now since this is, you're writing a one liner, doesn't mean it's a big O of 1 complexity. This internally runs this only. This internally will run this only. So there's no issue in that. Okay? So your count function is already made inside your C++. In your std, I told you yesterday, using namespace std, there is already a count function which is being used. Got it? Where you pass the array, where you pass this one, and you pass this. Cool. For people who are wanting to practice C++, कोई ज़रूरत नहीं अलग से practice करने का. What I will suggest you is start participating in contest. And when you participate in contest, you will see the use case of these algorithms. There is no need to do specifically on these algorithms. Just know this, remember this, and start solving problems. Whenever you are solving problems, if you require something like sorting, you use the sort. If you require something like a binary search, you can use the binary search. If you want to find the maximum element, you can use these algorithms. But do not specifically go and practice max element का questions. क्या मतलब है max का accumulate का practice करके? कोई मतलब है? सवाल शुरू करो जब जरूरत होगा जिंदगी में, जरूरत कर लेना. हर चीज को अगर practice करके expert बनना चाहोगे तो दिक्कत है. Start practicing, start solving problems. You'll yourself find the use cases of these. Don't specifically look out for questions. That's of no use when you are learning C++ STL. ठीक है? Sorting is n log n. Sorting is n log n, as I said you. ठीक है? Okay, now imagine 1 as a parameter, that is x. Any whatever number you want to count, you pass that as a parameter. Okay, similarly you can write in a vector as count vec.begin vec.end, and I can just give on the element 1, whichever is the element given by the user. Okay, maximum number of count. Okay, so that's not possible over here. We have to write normal. आपको कोड लिखना पड़ेगा. ठीक है? Any questions? Thank you. Can you sort in big of one time? No, that's not practically possible. If the array is of length n, how can you sort that in big of one time, right? You cannot. Okay, cool. So what we will do is, now we will find the next function, that is, just imagine there's an array, right? And the array is looking something like 1, 2, 5, 1, 2, 3. Okay, this is how the array looks. And I want you to find the first occurrence of, again remember this is an unsorted array, first occurrence of 2. So can you tell me where is the first occurrence of 2? It will be like, it is in the index 1, because this is the index where 2 occurs for the first time. If I ask you where does 1 occurs for the first time, 1 occurs first time here. Where does 5 occurs? Over here. Where does 4 occur for the first time? Over here. So if you're given any if you're given any element and you want to find the first occurrence of that, so it's a very easy step. Again, you'll just keep an index as -1, and you can just keep on looping from 0 till n, and you say if array of I is equal to the x, I can say index is I, and I can break out, and I can at the end of the day print index. Like, it easily tells me where is the first occurrence of x. So इसके लिए एक बहुत सिंपल सा फंक्शन है, इसके लिए बहुत सिंपल सा फंक्शन है. You just have to write that. That's known as the STL, the find function. So find first iterator, last iterator, and if you just give the element, it automatically finds that. ठीक है, cool. मैं आपको बता देता हूँ, यहाँ देखो क्या होगा. So if you just write क्या कमेंट्स आ रहे हैं? Okay, so see, if you just write auto of it find array plus n comma the element 1 or 2, it will return a pointer on an iterator pointing to the first instance of it, or else it returns pointing to the end if it is not there. So for an example, take this array. So if you say find 2, so you will get an iterator that points here. You will not get the index, you will get an iterator which points here. समझ में आ गया? You'll get an iterator. कौन है भाई हिंदी में बोलने वाला? कौन है? किसको हिंदी में चाहिए? Like, see guys, you need to grow up. See, if you always be in your comfort zone, you will never be able to crack these companies. Don't be in your comfort zone. Come out of that comfort zone, man. हिंदी में पढ़ा दीजिए, समझ में आ जाएगा यार. इफ यू ऑलवेज स्टे इन योर कंफर्ट जोन, आप हिंदी बोलते रह जाओगे, आप कभी भी बड़े कंपनीज में आ नहीं पाओगे. मैं इतना भी से बता दे रहा हूँ. Try to get out of your comfort zone. Try to understand English, because going forward, you're going to give all the interviews in English. You're going to work tomorrow. In offices, you have to talk in English, because generally in India, wherever you work in a product-based company, there's a mixture of North Indian audience, there's a mixture of South Indian people. So you have to speak in English. You have to deal with international customers. You have to deal with international people in your team. Again, you have to speak in English. So if you don't come out of your comfort zone of Hindi, no one is going to hire you. I'm going to tell you that very clearly. No one is going to hire you. मैं आपको हिंदी में समझा सकता हूँ, मेरे लिए बहुत आसान है हिंदी में समझाना. मैं ऐसे ही समझा दूंगा हिंदी में. इंग्लिश बोलने में इनफैक्ट मुझे थोड़ा टाइम लगता है, क्योंकि आई एम नॉट एन, मैं बाहर से नहीं हूँ, मैं इंडिया से ही हूँ, तो मुझे भी टाइम लगता है. बट कम आउट ऑफ योर दैट कंफर्ट जोन एंड ट्राई टू गेट इंग्लिश. अदरवाइज इंटरव्यू क्वेश्चन भी समझा देगा इंग्लिश में, आप फिर उसको बोले हिंदी में समझा. ऐसे नहीं होता है, राइट? अब कोई बोलेगा, हाँ कोई बोलेगा कन्नड़ा में पढ़ाओ, कल को कोई आके बोलेगा तेलुगु में पढ़ाओ, तमिल में पढ़ाओ, तो नहीं होगा ना. Let's learn in a language which everyone can understand in our country, right? A bit English is something which I personally feel everyone can understand, and if they cannot, there's a problem. You have to, like you have to. There is no other option. ठीक है? Get out of your comfort zone, man. कुछ चीज़ हासिल करना होता है ना, तो खुद को कष्ट देना पड़ता है. अगर इंग्लिश अच्छा नहीं है, आई सजेस्ट यू हाउ टू मेक योर इंग्लिश बेटर. घर में न्यूज़पेपर मंगाओ, रोज़ न्यूज़पेपर पढ़ो, इंग्लिश अच्छा होगा. इंग्लिश न्यूज़ चैनल देखो, हिंदी नहीं. नेटफ्लिक्स में अगर मूवी देख रहे हो, ट्राई करो इंग्लिश में देखने का, सबटाइटल्स लगा के. दिस इज हाउ यू इम्प्रूव, मैन. डोंट जस्ट रन अवे. ठीक है? Okay, I'll explain you. So basically what I say is, find me in this range, find me the first occurrence of 2. So where is the occurrence of 2? At this position. So I'll just use the pencil. Find the occurrence of 2. So you get an iterator which points over here. You do not get the index. So if you remember, I told you in arrays and vectors, if this is an array, all these are contiguous memory allocations. So if this is an 102 memory, this will be the 103 address of the memory. This will be 104 address. This will be 105. This will be 106. This will be 107. Remember, all the indexes are at contiguous. These I'm calling them as memory address. Okay, these are memory address, like which are internally in the computer, not indexes. Indexes are 0, 1, 2, 3, 4, 5. What I'm talking about is memory allocation. The memory allocation is always contiguous. The memory allocation is always contiguous. So if the memory allocation is contiguous, okay, so if you get an iterator which points to 103, how do you get the index? How do you get the index? In order to get the index, what you do is you subtract. I repeat, you will subtract the begin, because begin is pointing to 102. So if you are saying find 2, so find 2 will point here, which is 103. So this will give you 103 in terms of memory. And if you subtract the begin, this begin is nothing but 102. So 103 minus 102 get you as the index value. So if you subtract any iterator, remember this, if you subtract any iterator from the begin iterator, this always gives you the index number. Clear है? क्या सबको समझ में आ गया है? This always gives you an index number. Is that clear? चयन यार, ट्री सीरीज बनाने के लिए मुझे भी टाइम लगेगा. 50 वीडियोस एक दिन में नहीं बना पाता यार. आपको समझना पड़ेगा कि आई हैव एन ऑफिस, आई हैव अ पर्सनल लाइफ विच आई हैव टू, ऑब्वियसली आई हैव टू गिव टाइम टू. आई ऑल्सो टीच अ लाइव. मेरे पास काफ़ी काम रहता है. मैं दिन के 50 वीडियो नहीं बना सकता. 50 वीडियो आप कोई भी यूट्यूबर को पूछो, 50 वीडियो अगर कोई 50 दिन में भी बना देना, मैं अपना नाम बदल दूंगा. लोग ज्ञान वाले वीडियोस बनाते हैं, उसमें भी वीकली एक नहीं डाल पाते. आप कैसे एक्सपेक्ट कर सकते हो कोई बंदा 50 वीडियो 50 दिन में बनाए? इट रिक्वायर्स रिसर्च, C++ जावा कोड लिखना पड़ता है, वीडियो पहले रिकॉर्ड करना पड़ता है, फिर वीडियो एडिट करना पड़ता है, फिर रेंडर करना पड़ता है. ये एक दिन में पूरा काम एक वीडियो में पढ़ाने का नहीं हो पाता है. 50 वीडियो में एक दिन में नहीं डाल सकता, आप एक दिन में नहीं बना सकता. 50 वीडियोस इवन इन दी वर्स्ट केस, इफ आई टेक वन वीडियो पर, लाइक एक वीडियो बनाने में 1.5 दिन भी लगता है, तो भी 70-75 दिन लगते हैं. दैट इज वाई टोल्ड कि 100K हो जाए, क्योंकि मुझे पता है 100K होने में लगेगा 30-35 दिन. तो मुझे टाइम मिल रहा है बनाने के लिए. इट्स नॉट कि मेरे पास बना हुआ है मैं नहीं डाल रहा हूँ. समझने की कोशिश करो, ठीक है? ओके, टेल मी इफ दिस इज अंडरस्टैंडेबल. टेल मी इफ दिस इज अंडरस्टैंडेबल. टेल मी इफ दिस इज अंडरस्टैंडेबल. हैज एवरीवन गॉट दिस? हैज एवरीवन गॉट दिस? Has everyone got this? Just tell me if everyone has got this. Tell me if you have got this. Yes, yes, लिख दो, yes लिख दो. डाउट है तो पूछ लो. डाउट है तो पूछ लो. Yeah, today end actually points to the after this memory. After this memory there is 108 which is not allocated, right? So end actually points here. End actually points here. Okay. End actually points to 108. Got it? So always remember, in order to get the index, it's the current iterator minus the begin iterator. Okay. So I hope you have understood this. ये भी तुम जानबूझ के स्पैम करो. पहले ओपी करने आ गए, अब डाउट पूछ रहे हो. पहले तो डाउट नहीं था. ओके, सो नाउ इन ऑर्डर टू गेट द इंडेक्स, as I told you, can I write this? And the index where this 2 occurs is is it minus n, it minus 0. Can I say it it minus 0, or can I call it it minus r, because r is ultimately, whenever you say r, this means the first iterator. Remember this, in an array you don't have to write specifically r plus 0. If you write r, that means the first iterator is pointing to the first memory. So if you just do it, that will work. Even if you do find vec dot begin, vec dot end, and then if you just give 2 in vector, the index is it minus vec dot begin. The index is it minus vec dot begin. In array, the first index is arr. So that is how you generally write it. Okay, I'll just ask someone from the team to get this off, get this AB off. एक सेकंड रुको, बहुत स्पैम कर रहे हैं. एक सेकंड रुक जाओ, क्या नाम था? इतना स्पैम मत करो यार। अब नहीं, स्टार आईटी से इंडेक्स नहीं आएगा, स्टार आईटी से एलिमेंट आ जाएगा, समझने की कोशिश करो। स्टार आईटी से एलिमेंट आता है, एलिमेंट आता है स्टार से, ठीक है। परफेक्ट परफेक्ट, अभी समझने की कोशिश। और एक चीज, व्हाट इफ आई गिव यू एन एरे लाइक दिस and 1 comma 5 comma 6 comma 2 comma 3 and comma 5 comma 6, okay, and I give you x as something like 4. Can you tell me what will happen to it? Can you tell me what will happen to it? Vec dot begin, vec dot end, comma 4. What will happen to it? What will it return? What will it return? What will it return? Can you tell me what will it return? So imagine these are again 107, 108, 109. I've just taken random memory allocations. In the back side of the machine, this can be any random numbers. I've just taken random numbers. What will it return? Where will be the iterator pointing to? Where will be the iterator pointing to if I look for 4? If I look for 4, where will be the iterator pointing to? Which memory address? Which memory address will the iterator be pointing to? Yes, last element. Perfect, perfect. It will be pointing to the last element, 114. 114. So basically, remember this, basically, if this IT, yes, if I can say, if IT is equal to vec dot end, so I can say cout element is not present, or else I can say element is first present at this index, which is it minus vec dot begin. क्लियर है? बहुत इंपॉर्टेंट है, बहुत इंपॉर्टेंट ये समझना कि कभी भी कुछ होता नहीं है तो वो एंड को पॉइंट करेगा. इट विल ऑलवेज पॉइंट टू एंड, इट विल ऑलवेज पॉइंट टू एंड, राइट? परफेक्ट. यस यस, हम बता देंगे एलिमेंट कैसे काउंट करते हैं, सब बता देंगे. सो दिस इज हाउ द फाइंड वर्क्स. अगेन this is always not vector dot begin or vector dot end. This will always be, remember, this will always be something which is the first iterator comma the last iterator. It will always be first iterator comma the last iterator. ठीक है, चलो फाइंड हो गया, आगे बढ़ते हैं. Binary search, which was the most awaited topic, is the most awaited algorithm. This STL only works on sorted arrays. This STL only, Kunal, you cannot find that. You have to give the entire stuff. You have to give the entire pair if you want to find it. You have to give the entire pair, okay? Perfect, perfect. So this STL only works on sorted arrays. So what does that mean? You have to definitely give an array which is something like this, which is sorted in itself. Yes, which is sorted in itself, 1, 5, 7, 9, 10. So this is a sorted array. This is a sorted array. And just in case you want to know, does X exist, for an example 9, and you want to say true, 9 exists in my array. For an example, X is 8, so that's false because 8 doesn't exist in my array. So basically what you need to do is, this is the syntax: binary underscore search array, first iterator, last iterator. I've already told you this can be anything, and you give the element. This returns, I'll tell you how to find the index. Returns a true or returns a false. This is how this works. So I can say bool result equal to binary array comma array plus n, and you can give the element x, whatever is your x. If it is 8, it can be anything. And similarly, if you want to write this in vectors, this is going to be vec dot begin and vec dot end, and you can easily find out if that exists or not. How to find this? I'll tell you how to find this. It only gives you yes or no. Okay, Anish, just imagine if IT is pointing to 108, अगर नहीं मिला पुराने वाले एग्जांपल में, अगर नहीं मिला तो लास्ट एड्रेस पे मूव करेगा, करेक्ट, लास्ट एड्रेस पे पॉइंट करेगा इफ यू डोंट गेट इट. सो एंड पे पॉइंट कर रहा है एंड तुम बिगिन को माइनस करते हो तो डिफरेंस क्या होगा? एन होगा ना. अगर लास्ट इंडेक्स पे मिल जाता है एलिमेंट, तो जब माइनस करते हैं n-1 आता है. अब अगर नहीं मिल रहा है तो लास्ट पे करेगा तो n आएगा ना. गॉट इट अनिश? Perfect. Perfect. So this is how the binary search works: a first iterator, a last iterator. So you don't have to write extensively binary search. Again, what is implemented inside that? You can definitely Google about binary search. The implementation is not tough. You can understand that, but yeah, I'll prefer you that you can definitely read about binary search. I'm thinking of bringing in dedicated 4 to 5 video series. I'm not sure how many, but I'm thinking of bringing a dedicated series on binary search. So let me know in the comment section if you want something like a series on exclusively on binary search. But I tell you how this binary search के बारे में बताएंगे, लो बाउंड बोलेंगे, अपर बाउंड बोलेंगे, प्रॉब्लम्स करेंगे, इंटरव्यू स्पेसिफिक. अगर चाहिए तो बता देना, ठीक है, कमेंट्स में बता देना. सो दिस इज हाउ अ बाइनरी सर्च वर्क्स. लेट्स कम टू लोअर बाउंड फंक्शन. व्हाट इज दिस फंक्शन? Again, remember this is log n. This works in log n complexity. What about the lower bound function? ठीक है Preeti, find works in unsorted arrays. Okay, it works in unsorted arrays and the time taken is linear, big O of n. Whereas binary search, as I clearly stated, binary search only works on something as sorted arrays. If you remember, binary search only works in sorted arrays. Array has to be sorted. This is a sorted array, and the find function works in every kind of array, so the time complexity is more, whereas binary search works in logarithmic n complexity. ठीक है perfect. Cool. So let's come to the lower bound function. So imagine lower bound क्या देता है बता देता हूँ. Returns an iterator pointing to an element which is not less than, pointing to the first element, you can say pointing to the first element which is not less than x. That is what it gives. So first let's understand, after that I'll tell you the functionality. Let's imagine array is this. Okay, let's imagine array is this. After this I'll give you some questions too. Again, array has to be sorted. Okay, now if I give you x as let's assume I give you x as 10. So where will the iterator point? The iterator, this 10, what did it say? Element, the first element which is not less than x. 10, which is the first element that is not less than 10? And I said 10 is the first element that is not less than 10 because 8 is lesser than 10. So which is the first element that is not lesser than 10? Can I say this is the first element that is not lesser than 10? Can I? For 10? समझ में आ गया? क्या सबको समझ में आया? Is this the first element that is not lesser than 10? Right? That's the first element that is not lesser than 10. Has everyone understood this? 10 itself, not lesser than 10, not lesser than 10. 8 is lesser than 10, 8 is lesser than 10, but what I want is not, what I want is not. ठीक है, अभी आते हैं. If I change the x, what if I change the x to something as 6? If I change the x to 6, then where will it point to? Can everyone tell me where will this point to? Can you tell me where will this point to? Where will, if I change the value to x equal to 6, चलो comments से बताओ ये कहाँ point करेगा? If I change it to x equal to 6, where it will point to? Where it will point to? कहाँ point करेगा? Okay, a lot of people are saying 7. Okay. So, which is the first element which is not lesser than x? X is 6. 5 is lesser than 6. The first element is 7, which is not lesser than 6. The first element is 7, which is not lesser than 6. So, can I say it will point to this index or this iterator? Correct? Perfect, 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 perfect. So, ये भी समझ में आ गया. अब अगर मैं x की वैल्यू चेंज कर दूं, if I just change the value to something like 13, okay, where will this point to? Where will x equal to 13 point to? Comment में बताओ. Where will x equal to 13 point to? Remember, it points to the first element which is not lesser than x, so no middle का concept here. Okay, tell me where will x equal to 13 point to? कहाँ करेगा? Where will x equal to 13 point? And yes, and not garbage location. See, you don't have any element which is not lesser than, like, which is not lesser than 13, right? So can I say it will always point to the last iterator, correct? So I have told you all the use cases, it points to the first element, you can say, which is equal to or greater than that element. So what I've got is, I've got the use case of lower bound function. I've got the use case of lower bound function. Just in case you still have any doubt, you can ask me. It'll point to end, not r begin. R begin is this guy, end is right after that, end is here, r begin is this. Okay, so the syntax is very simple. Again, auto of it, lower bound array comma array plus n comma x, and if you want to get this index will be it minus array. And in case of vectors, that's going to be vector dot begin vec dot end comma x, and yeah, the index will be it minus vec dot begin. So that's about, again, a binary search is implemented inside this. I'll teach that in binary search का course में पढ़ा दूंगा. So binary search is implemented inside a low bound function. Yes, a binary search is implemented inside a low bound function, and hence this works in logarithmic of n. The time is very, very small that takes. Okay, समझ में आ गया? Again, works only in sorted arrays. You don't have to worry, it only works in sorted arrays. ठीक है? R begin लास्ट वाला एलिमेंट होता है, लास्ट वाला मतलब लास्ट वाला इंडेक्स का एलिमेंट होता है. C begin होता है, begin ही होता है, बट कांस्टेंट आइटरेटर होता है. इट्स अ कांस्टेंट आइटरेटर, so you cannot do anything to that iterator. तुम सोचोगे उस आइटरेटर के पोजीशन पे मैं वैल्यू चेंज कर दूंगा, तुम कर नहीं सकते. इट्स अ कांस्टेंट आइटरेटर. ठीक है? टाइम कॉम्प्लेक्सिटी रिटर्न्स, सी इंडेक्स नहीं रिटर्न करता, आइटरेटर रिटर्न करता है, फिर तुम माइनस करके उसका इंडेक्स निकाल लेते हो. सो अगेन यू कैन राइट दिस इन सिंगल लाइन ऑल्सो. सिंगल लाइन कैन बी जस्ट राइट द लो बाउंड and then subtract. Just write these. This is how you generally will find people using this. Just subtract. ठीक है, अभी हो गया. अब आते हैं upper bound के concept पे. What is this upper bound actually? Again, this returns an iterator which points to an element which is just greater than x, which is just greater than x. So again, let's take the same example and let's understand. So I'll give you just one hint, and I think you should be understanding. So if I ask you x is 7, so where will this point to? If I ask you x is 7, so where will this point to? This will point to this position. Just greater. Just greater. So if I'm giving you 7, it points to just greater. Got it? Has everyone got this? Yes, yes. All the functions that I'm saying only works in sorted arrays because the internal implementation is binary search, which again only works in sorted arrays. समझ में आ गया? जस्ट ग्रेटर का मतलब समझ में आ गया? ठीक है ठीक है ठीक है ठीक है ठीक है. अभी मैं x की वैल्यू चेंज करके तुम लोगों से पूछता हूँ, तो तुम लोग बताना क्या होता है. ठीक है. x is given as 6. So tell me where will this point to? x is given as 6. Where will this point to? If x is given as 6, where will this point to? प्रशांत, I've already answered you ना. Only works in sorted. बता चुका हूँ ना, बार बार पूछ क्यों रहे हो? I've already answered it. Only works in sorted because the internal implementation is binary search. Okay. Okay. Say 6 will point to 7. 6 will point to 7. This is where you guys went wrong. 6 will point to 7. 6 will point to 7, guys. 7, 7, 7 point करेगा. 6 है. Which is the just greater than this 6? 7 है ना? 7 को point करेगा. 7 को point करेगा iterator. Right? Perfect, 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 perfect. Let's change the value. Let's change the value of x. Tell me what will happen if I give you 12. Tell me what will happen if I give you 12. Tell me what will happen if I give you 12. The answer that it will be is right greater than 12. Do you have any element greater than 12 in the array? No. So this will point to the end. This will point to the end iterator, which is after this 12, which is after this 12, it will point. This will point here, it'll point here, right? Now, if I change the value to x equal to 15, this will also point to end iterator. Remember this. Just greater points to just greater. Points to just greater. Okay. Again, about the syntax, it's the pretty same syntax as this. The name only changes. The name only changes. It's rather an upper bound. Nothing else. It just change the name to upper bound. Just change the name to upper bound. There's no need to do anything else. Just change it to upper bound. That will work. So if someone asks you, if from today onwards, someone does tell you to find these kind of things, I think you should definitely can. So can you tell me? Can you tell me how to find? I'll give you a task. Since you know binary search. So just quick recap. Binary search is a Boolean function which gives you true or which gives you false. Correct? Lower bound gives you the element which is not lesser than x. Correct? Upper bound gives you the first element that is greater than x. So I give you 3 questions. So first question that we will solve, which uses lower bound and upper bound, is question 1 is find me the index where the element x lies. That's the first question that I want you to solve. Let's see who can solve this. Find me the first index, rather. Find me the, again you can use a find function. Find function can be used, but that takes big O of n time. Okay, so I'm saying the array is sorted, so that's the funda. Got it? Find function can be used, but that takes big O of n. Since the array is sorted, you have to use something like a binary search. So think, how will you get this first index using probably upper bound, using lower bound? Who knows? Tell me how you get this. Tell me how you get this. So this is the input and this is the x given to you. So tell me where this x exists. कैसे करोगे फटाफट बताओ. देखते हैं कौन बताता है. लो बाउंड दे देगा पक्का पक्का? तो सोच के बताओ एज केसेस होता है, इट्स कंपेटिटिव प्रोग्रामिंग, it's interviews, it's data set algorithms. Think of the edge cases. Will it always give? Think about that. Will it always give? Think about that. But will it always give? सोचो क्या लोअर बाउंड हमेशा देगा? अपर बाउंड माइनस लोअर बाउंड? नहीं 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 नहीं, थोड़ा सोचो. अपर एंड माइनस लोअर तो नहीं देगा. आई वांट द फर्स्ट ऑकरेंस, कैसे जाएगा, कैसे आएगा? सोचो थोड़ा सोचना पड़ेगा यार. कैसे? ऐसे थोड़ी होगा. अपर माइनस लोअर थोड़ी होगा. सोचो यार, सोचो. देखो, नहीं नहीं नहीं, अपर बाउंड समझ नहीं रहे हो यार. ये देखो, अगर ये एरे लेता हूँ, ये एरे ले लेता, ठीक है. इमेजिन दिस इज द एरे एंड आई आस्क यू टू फाइंड x equal to 8 or 7. Then the lower bound works. Then if you write something like lower bound of array comma array plus n, then it works. This, and you just do a minus of array, this will give you the index because 7's lower bound will be this 7. So you get it. But what if I tell you find x equal to 6? Then will this lower bound work? Think on this. Will this work? नहीं भाई बा, नहीं काम करेगा. बाइनरी सर्च तो बोलेगा है कि नहीं, बट ये तो काम नहीं करेगा, है कि नहीं? नहीं करेगा. इट विल नॉट वर्क. So there are two ways to do this. Yes, perfect Kunal, perfect. So if you just, there are a couple of ways to do it. The first way is, there are couple of ways to do it. First way बताता हूँ. First way is, do a binary search. If it exists, then the answer is definitely this. No doubt. And if it doesn't exist, then I'll say it doesn't exist. That's the first way. But over here, I'm using couple of binary search. Over here, I am using couple of binary searches. Because this is a binary search which is log n. This is a log n. So 2 log n. Log n plus log n. 2 log n, that is what I'm using. But I don't want to use 2 log n's. Can I simply do it using lower bound? So that's the second way. Can I simply do it using the lower bound? Think about that. Yes, I can. What if I write int index equal to this? And after this I say, if index is not equal to n, which means it's not pointing to the end, क्योंकि समझो, अगर एलिमेंट नहीं है, so index will point to n, which is the last index, end iterator. If it is not pointing, and array of index, whatever index I've got, if that's equal to x, can I say I have found my element? Can I say found at index? Indeed. Or else, if it is pointing to n and it is not equal, can I say not found? As a second way. Go through those and tell me if this is clear. Over here I teach random topics. कोई भी टॉपिक उठाते हैं एंड पूरा उसको, जैसे प्राइम पे आई हैव टॉट प्राइम completely. I've taught recursion some bit, probably I've taught C++ STL completely. I'm thinking of bringing something like binary search, bit manipulation. So yeah, let's see कब तक पढ़ा सकते हैं. जब तक हिम्मत है पढ़ाते जाएंगे. समझ में गया? Is this clear? Get me a yes if this is clear so that I can move forward to my next question. Get me a yes if this is clear so that I can move forward to my next question. Remember, this is very important. Make sure you check it. Because if you don't check it, let's imagine. If you do not put a check, what will happen? Understand what will happen. If you do not put this check, and I have this, and I say find x equal to 13. So the index will come as the last index 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Index will come as 11, which is out of bound. Hence, array of 11 will give you runtime error, because array of 11 doesn't exist, because the indexing is only up to 10, because the indexing is only up to 10, right? So this will not work. Remember this, very very important that you just make sure you follow these techniques. So in competitive programming, always remember, if you're accessing an index, always make sure that index is inside your range, ठीक है? हाँ, ये पूरा कोड मैं शेयर कर दूंगा, ये पूरा क्लास, तीनों क्लास का कोड है, मैं ID1 पे डाल के शेयर कर दूंगा, ठीक है? ओके, सो दिस इज डन. Everyone has done this question, right? I'll come to the next question. ठीक है? Next question पे आता हूँ. We'll do a poll about it. क्या चाहिए next? Let's come to the next question. Find me the count of occurrences. Okay, find me not count. Find me the last occurrence of x. Tell me how you do this. Find me the last occurrence of x in an array. So basically what this the question means is, what if I give you the array like this? Okay, this is the indexing, and I tell you last occurrence of x is equal to 10. So the answer for this will be 7th index. Yeah, just go through this question. I think you should be clear. Go through this question, you should be clear. Tell me. How do you do this? भाई n-1 होगा. नहीं, सही है. अब बस चेक कर लो, इज नॉट इक्वल टू n. तो इसका मतलब अगर ये नहीं है तो वैलिड इंडेक्स है. So tell me, how will you do this? Last occurrence of x. अगर कोई बोलता है give me the last occurrence of x, you might get a question like this. So how will you find that? Come on, think. How do you use this function? Upper bound -1. Okay, let's think about that, if that is correct. Okay, just checking upper bound -1, or what will you do? Will you just do an upper bound -1, or what? Why will you? That is wrong, na? अरे binary search. Traverse using r begin नहीं करना है ना? That is big of n, right? Upper bound -1. ठीक है, perfect. समझ में आ रहा है? सबको आ गया? So can I say? If I do an upper bound of 10, that will always point to 11. That is always point to 11. If I do an upper bound of 10, because it points to the next element, the greater element than 10. So can I say it will always point to this index? And if I just do a minus, so can I say if int index is equal to upper bound of array comma array plus n comma x minus array. Hence, but am I sure that this is my answer? Because what if I give you to find, last occurrence of x equal to 6? So your answer will be doesn't exist. So always be very careful. Whenever you're taken this, right? So the index will reduce by 1, because upper bound of 10 will point to this position. Upper bound of 10 will point to this position, correct? So this is index as of now. This is index at this position. So the moment you do an index -1, index comes over here. So you need to check if this guy is actually equivalent to your 10 or not. You have to check if that is equivalent to your 10 or not. Why do you need to do that? I'll tell you. See, abhi kya hoga? If x is 6, where will the upper bound index point to? The upper bound index will point to this guy, correct? The moment you do a -1, what will happen? The index will start pointing to this. So this 5 is actually not the last occurrence. So you have to be very specific while checking. Okay, you have to be very specific while checking. So if I just write the check, is this correct? Do you see any edge cases that I miss? Do you see any edge cases that I miss? Tell me if I miss any edge case. Tell me if I miss any edge case. Tell me if I miss any edge case. No, you can use upper bound to do that. Now remember, very important thing. If you're doing a -1, let's take a value. Last occurrence of x equal to 0, right? So can I say the upper bound in this case, can I say the upper bound of x equal to 0 will point here? The moment you do a -1, the index will come one step back, which is the -1th index. So do you need to put a condition check that index has to be greater than equal to 0? Has to be greater than equal to 0, because it might happen for certain cases when the upper bound points to the 0th index and then you do a -1, it turns out to be a negative index. And if you just do a negative index ka check, you will get a runtime error because that index doesn't exist. Is that clear? Is that clear? Is that clear? राइट, क्लियर होगा सबको? अब जो डाउट्स है चैट पे लिख दो, जो डाउट्स है चैट पे लिख दो, मैं लेता हूँ, सारे डाउट्स ले लेता हूँ. अभी जो डाउट है मैंने डाउट मिस आउट कर दिया, सारे लिख दो चैट पे, मैं ले लेता हूँ. जस्ट राइट इट ऑन दी चैट्स, आई विल टेक ऑल दी डाउट्स. जस्ट राइट इट ऑन दी चैट, आई विल टेक ऑल दी डाउट्स. राइट इट ऑन दी चैट, आई विल टेक ऑल दी डाउट्स गाइस. नेक्स्ट परम्यूटेशन आ रहा है इसके बाद आएगा. क्लियर है? एनी डाउट? If x is 13, okay, let's do this. What if the x is 13? See, if x is 13, what will happen? Where will the upper index point to? कहाँ point करेगा? यहाँ पे, which is the 11th index. The moment you do an index -1, it will point to here. It will check if this 12 is equivalent to your 13, and it will not found, and it will say it doesn't exist. Got it? Got it, Trishal? Got it? ये क्वेश्चन मत पूछो, why array starts from 0th index. Don't ask me this why array starts from 0th index. जो जिस बंदे ने इसका आविष्कार किया है, आप उनसे जाके पूछे, ठीक है भाई. लोअर बाउंड में इक्वल का केस कैसे हुआ? 10 वाला एग्जांपल. जब तुम 10 का अपर बाउंड करेगा ना, तो इंडेक्स हमेशा इधर पॉइंट करेगा अपर बाउंड करने से. तो अपर बाउंड का -1 ही तो लास्ट ऑकरेंस होगा, है कि नहीं? For people who have just joined, please watch the recording. I cannot repeat for people who have just joined because that will create a mess. I have 120 constant watching, so I'll get it right. Has everyone got it? Okay. Perfect. So everyone got this right? Everyone got that? तो अभी आते हैं next question पे अपन. So last occurrence, first occurrence हो गया. Last question which might be asked involving upper bound and all this. Tell me the number of times the x appears in array. So if I give you this array, and I tell you कि कहाँ occur करता है. If x is 10, the answer is equal to 3 because it appears thrice in the array. If x is 7, the answer is 2 because it appears twice in the array. Is the question clear? Is the question clear? How many of you are from my college? Are there any people from my college by the way? कोई है क्या मेरे कॉलेज से? कोई है क्या मेरे कॉलेज से? बता सकता है कोई है तो? कोई बता सकता है? Anyways, आप तब तक ये बता दो, फिर मैं बता दूँ. A lot of people are saying. How will you do this? Think. How will you do this? Upper bound minus lower bound. Okay. There is nothing a C++ roadmap. See, you learn how to write a for loop. You learn how to write a while loop. You learn how to take an input, how to do an output. That much is more than enough to start programming. After that, watch my STL. You learn the entire STL. Start programming. And the rest things you'll keep on learning while you solve problems. Whatever is required, you'll keep on learning during the course. But don't always sit back कि मैं पूरा सीख जाऊंगा फिर शुरू करूंगा. वो कभी नहीं आता. वो दिन कभी नहीं आएगा. ठीक है? Okay. It looks like only one people. Okay. Okay. Which colleges are you people from? किस कॉलेज से हो? सारे किस कॉलेज से हो? अरे IIT रुड़की हो. Nice. Heritage, nice. St. Thomas, great. So how will you do this? So just imagine if I do a low bound of 10, where will that point to? If I do a low bound of 10, where will that point to? That is the biggest question. Let's check that out. Okay, so if I find a low bound of 10, where will that point to? The lower bound will point to this, correct? And if I do an upper bound of 10, where will that point to? This. So that's index 5, that's index 8. So if I do a upper bound minus lower bound, which is index 8 minus 5, will I get 3? Which is indeed the number of occurrences. Right? Okay, let's check out SRM, PICT, IIIT, Panipat, Chegaon, JIS College, NSEC, Kolkata, Netaji Subhash, GGC, JIS, JGC, Vistula University, RCC Institute, Camellia Institute, Kolkata. Nice. Okay, so upper bound minus lower bound, you have got it, right? Upper bound minus lower bound, right? Let's change the example. And let's take something as 7. Okay, what will happen in case of 7? Okay, not this. Let's take x equal to 6. So in this case, x equal to 6, where will the lower bound point to? The lower bound will point to 7. Where will the upper bound point to? 7. So the upper bound and lower bound points to 7 is the index 2. So if you do an upper bound minus a lower bound, which is 2 minus 2, which is 0 elements. So 6 doesn't appears. So I actually figured out for doesn't appears, and I also figured out for if it appears. So I think it's working. So can I see the formula for the number of times the x appears is upper bound minus lower bound, which again the complexity becomes twice of log n, because something like upper bound takes log n, something like lower bound takes log n, so it becomes twice of log n. Got it? Perfect. Has everyone got this? Has everyone got the complexity and how do you find this? सबको समझ में आ गया. बस सबको आ गया तो फिर मैं आगे बढ़ूंगा. अगर सबको आ गया तो मैं आगे बढ़ जाऊंगा. No, there's no need to. Let's take an example. There's no need to put a check. There's no need to put an external check. What if x is 13? Okay, so imaginary index 11. This is where the upper bound points to. This is where the lower bound will point to. So if you do an 11 minus 11, you'll get 0. It doesn't exist. So you don't have to write any external checks. You just print upper bound index minus lower bound index. You automatically get your answer. There's no need to put a check, because if it doesn't exist, ideally, if it doesn't exist, the upper bound and lower bound are pointing to same index. If it doesn't exist, so you don't have to put. X will always be continuously present, because it's a sorted array. X has to be continuously present. It's a sorted array, guys. If it's a sorted array, the 7 will be together only. the 7s will be together, the 10s will be together, then the 11s will be together. It's a sorted array, guys. Common sense, right? Cool. So has everyone got the entire binary search concept? I'll give you a quick recap, and after that you can just give me a yes. First was binary search, which tells you if it does exist or if it doesn't exist, right? True or false. Then there was lower bound, which tells you the element that is not lesser than x, the first element that is not lesser than x. Then came upper bound, which points to the element that is slightly, the first element that is slightly greater than x, correct? And we solved 3 problems. Again, you have to put checks. So clear hai sabko? Fatapat yes likh do. I'll go to the next thing, which is next permutation. I'll go to the next thing, which is the next permutation. Go to the next thing, which is next permutation. Yes लिख दो, फटाफट नेक्स्ट क्वेश्चन पे चले जाएंगे. यस आ गया? यस फटाफट लिखो. नेक्स्ट क्वेश्चन पे जाते हैं, नेक्स्ट परम्यूटेशन. आ गया? अनअकैडमी 26 को शुरू हो जाएगा. 26 को शुरू हो जाएगा. एंड यहाँ पे ऐसा नहीं होता 2 महीने पहले प्रमोट होता है. 1 वीक पहले प्रमोशन शुरू हो जाए, मतलब सबको बताया जाएगा 1 वीक पहले ही. इट वॉन्ट टू लाइक, यहाँ पे ऐसा सब जैसा नहीं होता कि भाई 1 महीने पहले से बोलना शुरू कर. कम इट विल बी displayed 1 week before. So you can follow my educator profile. You'll find that in the link in the description. And जब भी enroll करो मेरे कोर्स के लिए, make sure you use the coupon code striver. Make sure उसको यूज़ कर लेना, striver को यूज़ कर लेना, so that 10% मिल जाए. ठीक है, चलो. So next आते हैं. बियर्ड बढ़िया लग रहा है, बहुत धन्यवाद अक्षत. Okay, let's get started. So next permutations. So when I say string s equal to abc, what are permutations? Permutation means the first permutation is ABC, the next permutation is ACB, the next permutation is BAC, but the next permutation is BCA, but the next is CAB, but the next is CBA. So these are called permutations. What is permutations? When you permutations क्या होता है? सारे combinations. ABC को आप अगर घुमा फिरा के लिखोगे, आप ACB लिख सकते हो, आप BAC लिख सकते हो, घुमा फिरा के लिखो. मतलब the characters are ABC. There are 3 characters A, B, C. अब घुमा फिरा के लिखो, so you'll get ABC, you'll get ACB, you'll get BSC, you'll get BCA, you'll get CAB, you'll get CBA. So these are the permutations. Okay, these are the permutations. Again, I've just taken an example string. The string can be anything, and all the permutations are in the sorted order. If you carefully observe, all these permutations are the sorted order. What is sorted? Lexicographically sorted. अगर आप dictionary में देखोगे, if you look in the dictionary, ABC always appears first, then ACB, then BSC, then BCA, then CAB, then CBA. Remember? Again, over here I have taken a string. Probably it could be an array also. They can give you an array like this also. They can give you an array 2, 1, 3. आप इसका भी सारा permutation लिखोगे तो 1, 2, 3 आ जाएगा as an array, and then there will be a 1, 3, 2, then there will be a, see, permutation can be for strings, can be for array elements, can be for vector elements, can be for anything, right? I'm just explaining you by taking an example of a string. You can do that using an array, you can do that using a vector also. All elements when permuted, you get all these, and this is lexicographically sorted. Lexicographically means how they appear in a dictionary. ठीक है? Perfect. C++ STL पूरा था, प्राइम पूरा था, आगे जाके देखते हैं. It all depends on the response. अगर मैं पढ़ा रहा हूँ 5 जन आ रहे हैं तो फिर obviously full पढ़ा के क्या फायदा है? It all depends on the response. ठीक, फटाफट. So permutations हो गए. So what is the next permutation? So there is something known as next permutation. ठीक है, अभी next permutation क्या करता है? So for an example, let me give you something like this. String, let's assume the string is given as BCA. Okay, string is given as BCA, and write next permutation. Remember, in string also you can write begin and end. So you write string begin, string end, right? If you just write this, so, and this returns a true or false. Remember this. If you write this line, what will happen? I'll tell you. So this result will get, so okay, by the way, sorry. Okay, perfect, sorry. So this is the rest. Okay, now the string is BCA. Where is the string? The string is here. If you carefully observe, the string is here. BCA is here. ठीक है. So अगर BCA इधर है, and मैं बोलूँ next permutation क्या है BCA का? So can you say the next permutation is CAB? So the moment you apply next permutation on the string after this line has been executed, after the line 918 has been executed, the string will become CAB. Remember, the string will become CAB automatically, and this resultant that will be returned will be a true value. Why true? I'll tell you. Basically, when you apply next permutation on a string, the string gets to the next permutation, okay? And if it gets to the next permutation, it returns a true. So what happened over here? Initially, you took a string as BCA. The moment you applied next permutation, BCA moved on to CAB. So the string becomes CAB. And since it becomes CAB, if it gets, it returned a true, which can be stored in your resultant. Clear hai? Is that clear? Clear हो गया? एक्सपेरिमेंटेशन का लॉजिक क्लियर है? अभी आएंगे और एक केस है, बट इज दिस क्लियर? एज ऑफ नाउ इज द नेक्स्ट परम्यूटेशन क्लियर? क्या आता है अभी? क्लियर है कि नहीं? बता दो यस बता दो, तो फिर मैं नेक्स्ट मतलब और एक एच केस है इसका बताता हूं. Got it? I'll tell you what is the use of true. I'll tell you. यूज ऑफ ट्रू बता दूंगा. ठीक है, ये हो गया. अभी देखते हो. अभी फॉर एन एग्जाम्पल if I give you something else. Yes, low bound works on an array or on a container if that container is sorted. It can have integer, it can have doubles, it can have character, it can have strings. It should be in the sorted order. Simple as that. ठीक है, अभी आते हैं. What if I tell you कि I have the string as CBA, ठीक है, and I apply the same line. Assume the string is given as CBA and I apply the same line. Then what will happen is CBAs, do you find कोई है इसके बाद? क्या इसके बाद कोई है? नहीं, there is no one after this. So there is no next permutation. So after this line is performed, the string still remains as CBA, but it did not get. So what you will do is you will return a false. So this rest value will indeed be false. So if it gets the next permutation, the string changes to the next permutation, right? And if it doesn't get, it returns a false. If it gets, the string gets changed, returns a true. If it doesn't get, then the string definitely returns a false. Clear है? कल नहीं है, ये last class है. This is the last class for C++ STL. Not tomorrow. This is the last class for C++ STL, guys. I want to cover everything. Don't worry. Probably today थोड़ा late हो जाएगा, but ठीक है, चलेगा, चलता है. Clear हो गया? No, after this we have a previous permutation, and yes, we definitely have comparators, which I'll quickly cover. ठीक है, समझ में आ गया? Is this clear सबको? Next permutation क्या करेगा? Clear है? It gives the next permutation on that sorted order. It gives the next permutation, and if there doesn't exist, it gives you a false. If it exists, it converts the string as well as it gives a true. ठीक है? Clear now? Perfect. So what if I give you a question where I tell you कि hey, I give you any random string. I give you tomorrow which topic? Tomorrow probably I had a tumor here, so I had to operate that. So that is why I cannot speak for longer hours. Like I cannot speak for 3 hours or something like that. Okay, if I give you any random string, for an example, string equal to, I give you BSc, okay, or a BCA. I want you to print all the permutations. How you do that? Can you tell me how you do this? Because the next permutation only gives you the next permutation. So if I give you a random string BCA, I give you any random string, and I want you to print this entire line number 908 to 913. How will you do that? The complexity is big O of n. Yes, the complexity is big O of n. For people who are wanting to know how is this implemented, I've already made a video on this. I've already made a video on my Take You Forward channel. You can definitely check it out. I have given the entire intuition. How is this next permutation implemented? Just write next permutation on YouTube. You'll get my video. ठीक है? अभी इसका बताओ क्या होगा? If I give you any random string SBA, I want you to print all the permutations. How will you do that? Using this next permutation, obviously. Using this next permutation. This is the question for the day on this algorithm. That's the question for the day on the algorithm. Sort करके next permute करके. Perfect, Trishul. Perfect. So can I say the starting is ABC. The starting is ABC. So what if I've been given the string, for an example, I've been given the string as BCA. The moment I sort the string, again as I said, any container will have its first iterator and the last iterator. Can I say this makes the string as ABC? Correct? This will make the string as ABC. Right after that, can I write a do while loop where I say next permutation s dot begin. See what will happen. If I write this and over here I say C out of S and L, what will happen? See क्या होगा? समझने की कोशिश करो क्या होगा. First S came as BCA. I sorted it, so the string will become ABC. Goes inside the do loop. C out of S. So ABC gets printed. Goes to the while loop. Does the next permutation of S. So now S is this. And the next permutation returns a true. So while says true. Again I'll go to the do while loop and I'll again print the S. So this is printed. Again I'll come to the while loop and next permutation will again take this to the S. And again this next permutation will return true. So this will be printed. And again it will keep on going. At the end when CBA will be printed now. Then while loop, when does the next permutation on CBA, it gets as a false and it stops. So did you understand how do you print all the permutations using next permutation? Did everyone understood this? Next permutation की जो complexity है, that's big O of n. You can definitely check out my video on this. I've already made a video on this. It's a big O of n है. ठीक है? You can check out my video. Cool. So is that clear about next permutation? Clear again? Next permutation. How to print all those permutations. Sorting is very important. So if I talk about the complexity, if I do the complexity analysis, how many permutations can you have? The number of permutations generally is n factorial. So first you are sorting this. So the sorting time is n logarithmic of n. The sort takes n logarithmic of n. And how many times will this do while loop run? N factorial times, because there are n factorial permutations. And what are you doing? You're basically calling an next permutation, which is a big O of n, which is again negligible when you talk about n factorial. So I can say the complexity is huge because you're taking almost n factorial time, because there will be n factorial permutations always. Why will there be n factorial permutations? Very simple. Because if there are 3 characters, how many options do you have to fill up this 0th index? कितने options है? तुम A fill कर सकते हो, तुम B fill कर सकते हो, you can fill up C. So there are 3 options. 3. How many options do you have for 1? There are 2 options, because अगर इनमें से out of this you have chosen one. If you have chosen one, for this guy, how many options will be left? 2. For this guy, how many options will be left? 1. So how many way is 6? And that this is nothing but n factorial. 3 cross it, 2 cross it, 1 is nothing but n factorial. Hence the total number of permutation is n factorial. Got it? I just used a do while because I wanted to stop, because I wanted to print the first string, and then I wanted to do a next permutation, and then I wanted to print the string, then again wanted to do a next permutation, so that I can move from here to here, then from here, then from here, then from here, then from here, and the moment I wanted to move from here, this will return a false and the while loop will stop. Do while is generally used when you want to execute the first time, and after that you want to check a condition. Got it? And you cannot simplify n factorial because there are n factorial, so you cannot simplify that. ठीक है? Perfect. सबको आ गया समझ में? सबको आ गया समझ में? Has everyone got the next permutation? Is it crystal clear? Is it crystal clear, guys? Crystal clear है? Next permutation. Very very important algo is asked in a lot of interviews. Again, in order to understand, this is the STL way. This is the STL way. Again, if you just want to do this using recursion, I have a video on this, you can check it out. If you want to do this using recursion, you check out my video, or else I can teach you over here, probably in some other class. But if you want to know how to do this using recursion, you can check that out. ठीक है? Perfect. समझ में आ गया? अब आते हैं आगे बढ़े. लॉन्गेस्ट स्ट्रिंग्स में इन फैक्टोरियल आप प्रिंट नहीं कर पाओगे, मशीन हैंग हो जाएगा. लॉन्गेस्ट स्ट्रिंग्स में सारे परम्यूटेशंस आप प्रिंट नहीं करा पाओगे, मशीन हैंग हो जाएगा. आगे बढ़ू. Shall I move ahead? Cool. This is the STL way. Do not follow this in an interview. This is okay for competitive programming. Do not follow this in an interview. In an interview, it should be the recursive way. Okay? Perfect. So, abhi aate hain अपन next way, which is the previous permutation. Do I need to explain this? As the name suggests, do I need to explain this? Do I need to explain the previous permutation? आप बताओ मैं explain करूँ? Do I need to explain the previous permutation? आप बताओ मैं करूँ कि नहीं? मतलब आई थिंक ये तो क्रिस्टल क्लियर अभी तक हो ही गया होगा. अरे इंटीजर में क्या होगा ब्रो? आप एरे लिखोगे, एरे पे होगा वो काम. यहाँ पे एरे हो जाएगा और क्या. इंटीजर पे यार क्या होगा? ये क्या कर रहे हो यार? इंटीजर पे क्या होगा? अगर इंटीजर होगा तो क्या है, क्या प्रॉब्लम है ब्रो? इफ इट्स एन इंटीजर, you store it as an integer, right? It's an array, right? Just store it as an array. खत्म बात. ये लो array 1,5,6 int n is 3 over here, so just write array comma array plus n, sorted. And over here what will be? String of array. पूरा array print करना है ना, तो array के लिए तो loop चलाना पड़ेगा. चला दो. Right? And this will be c out of handle. And यहाँ पे क्या होगा? array comma array plus n. क्या प्रॉब्लम है ब्रो? ये नहीं कर सकते तो क्या कर पाओगे? ये तो हो गया. क्या डिफरेंस है बताओ? There's no difference, man. In a string, it's a begin end as an iterator. In an array, it's an array comma array plus n as an iterators. And this is simple print. A simple print function. Nothing different, man. Nothing different. Perfect. अरे प्रैक्टिस प्रॉब्लम्स ही तो करा रहा हूँ. ये प्रॉब्लम्स ही तो है, ये सारे प्रॉब्लम्स ही तो है. बाकी when you do competitive programming, when you solve in lead code, you'll use them, right? And everywhere you'll use them. Probably it will be dynamic programming, probably it will be trees, probably it will be bit manipulation. Over there you'll use them. So you have to learn those topics, right? So there is no like specific questions. यही है, सारे permutation print करो, ऐसे ही questions रहेंगे. समझ रहे हो? डू वाइल कंडीशन यार क्या एक्सप्लेन करना है. फर्स्ट टाइम वन, ये देखो, फर्स्ट टाइम एबीसी प्रिंट होगा, वाइल पे गया, इधर आ गया, फिर प्रिंट किया, फिर वाइल पे गया, फिर प्रिंट किया, वाइल पे गया, प्रिंट किया। डू वाइल तो इजी है यार, खुद समझो यार ये सब, ठीक है। प्रीवियस परम्यूटेशन हो गया ना सबको, विराट कोहली ऑफ कोडिंग, ओ भाई साहब। ओके, नेक्स्ट परम्यूटेशन, previous permutation is clear, next permutation is clear, right? So this will moreover complete your algorithms. Like these are the algorithms you need to know. Generally these will be the ones that will be used. There are multiple more algorithms, but that they will never be used, hence you don't need to concentrate on them. Concentrate on these algorithms, specifically lower bound, upper bound, binary search. These will be used always. Next permutation is again a very good algorithm which will be used in a lot of places, ठीक है। अब आएंगे कंपैरेटर पे, which is again, so what is this comparator all about? आते हैं, ये कंपैरेटर भाई है क्या, ये तू कौन है कंपैरेटर भाई, ये सबको, I mean if you know comparator, and if you know comparator, by the way, anyone knows comparator? As I said, keep doing code forces, you'll probably get these algorithms used. Don't expect random problems. Like, try to start solving code forces, start solving code chefs, start solving lead code. You will see these kind of stuffs being used. You don't start solving and you just wander on, प्रैक्टिस करूंगा सी प्लस प्लस STL प्रैक्टिस करूंगा। अरे नहीं होता, शुरू कर दो अपनी इस जर्नी प्रॉब्लम सॉल्विंग की, ऑटोमेटिक these things will be used. डोंट सिट बैक एंड थिंक यार मैं नेक्स्ट परम्यूटेशन का 50 प्रॉब्लम करूंगा फिर शुरू करूँ, नहीं होता वैसे। पता चल गया ना, ये इससे ये होता है, शुरू करो, जब जरूरत होगा यूज कर लेना, जबरदस्ती जरूरत का प्रॉब्लम्स मत खोजो, क्योंकि ये दूसरे प्रॉब्लम्स में इंप्लीमेंट किया जाएगा तो प्रॉब्लम सॉल्व तब सिर्फ इनसे हो जाएगा, लॉजिक बहुत लगेगा उधर, तो इधर तब इसका यूज करना है लॉजिक, बट उधर लगेगा, यूज सिर्फ करना है, हाँ भाई दे दे, वैसा होगा ये केस, समझ रहे हो? Yes. So basically, let me explain you what is a comparator. Let me explain you. First of all, if you write sort array comma array plus n, this is a pattern of writing which sorts everything in ascending order. Okay, so if you want to sort them in descending order, array comma array plus n, you have to write a function comparator. Again, the function name can be anything. You have to write a function comparator. Remember this. You have to write a function comparator. And this comparator function has to be returning true and false. So, how do you write this function? It's a boolean function. ठीक है? कैसे लिखते हैं समझने की कोशिश करेंगे अभी. So, let's go to the top. I think I've written a lot of code in these 2 days. Right? So, let's go to the top. And let's just quickly right over here. So boolean comparator. What is your array? So in order to write comparator, I'll just teach you a trick. A very simple trick. जिंदगी भर याद रखना है, comparator लिखने में कोई दिक्कत नहीं होगा. Remember it lifelong. You will never find a problem in writing a comparator. ठीक है? Just for an example. I still want to sort them. I want to sort them in descending. I have an array of integers. I want to sort this in descending. So, in order to write a comparator, the technique is very simple. Always consider two elements. Element 1 and element 2. Forget about the array. Consider element 1, consider element 2. ठीक है? Remember, अगर element 1 हमेशा if the element 1 is before element 2, you will return a true. If it is not, you will return a false. That's the funda. I'll explain you. Don't worry, I'll explain you. So, you write integer element 1. भूल जाओ array. सोचो, just forget this is an array. यार एक जन स्पैम क्यों कर रहे हैं? फिर से वही आ गया हिंदी में बोलना है तो फिर आप एक काम करो, आप पढ़ो मत, पढ़ाई क्यों कर रहे हो, छोड़ दो. वाई आर यू प्रिपेयरिंग फॉर इंटरव्यूज? नहीं काम कर पाओगे, कल ऑफिस में जाओगे भगा देंगे उधर से. अगर हिंदी इतना ही प्यार है भगा देंगे, मैं बता रहा हूँ, साफ बता दे रहा हूँ. अनलेस अंटिल यू गेट एन ऑफिस इन नोएडा, गुरुग्राम, then you might survive. but or else people will just shut you out of the office. Okay. Comparator. Remember, do not think of the array. What is the array comprising of? Integers. What? हाँ notes दे दूंगा, पूरा ही दे दूंगा, टेंशन में. What is the array comprising of? Element 1. Array is comprising of integers. यार spam मत करो यार, spam मत करो. I'm teaching, I get distracted by the spam. Please don't spam. Otherwise I'll have to block you. Please don't spam, man. ठीक है, अभी ये करते हैं. So देखो, whenever it's an array, it's an integer array. Forget about the integer array. Think about two elements. Only two elements. Element 1, element 2. Two element को बस sort करना है. सिर्फ यही सोचो. You have to sort two elements only. Element 1, element 2. ठीक है. So if element 1 is already smaller than element 2, think. If element 1 is already smaller than element 2, so can I say they are sorted? Element 1 is at the top, element 2 is at the bottom. So in array it is already sorted. Just think of two elements. Element 1 is the starting element, element 2 is the second element. So if element 1 is already smaller than element 2, element 1 is at its correct position. Okay, so it's basically something like, you just imagine an array of two elements, element 1, element 2. If element 1 is smaller than element 2, so can I say they're already sorted? You don't need to do anything. So you will always return a true because they're already sorted. Or can I say, if it is lesser than equal to, can I say if it is lesser than equal to, if element 1 is lesser than equal to element 2, can I say it is already sorted? Indeed I can. If element 1 is lesser than equal to element 2, they're already सही position पे. अगर नहीं है तो return false कर देना है. This is how you write comparators. Always think of two guys. And then try to write a equation. Element 1, element 2. क्या element 2 छोटा है? मतलब वो सही position पे है. मैं लैपटॉप में देख के नहीं पढ़ा रहा हूँ. For your example, I'm using this iPad. I am reading chats over here. So please stop spamming and stop doing this, right? This is getting out of hand. Please. Yeah, I've asked them. Anyways, so always think of couple of elements. That's element 1 and that's element 2. And you always say, if element 1 is lesser than equal to element 2, you return a true or else you return a false. Okay? Perfect. समझ में आ गया? So just give me yes if you have understood the comparator. Just give me yes if you have understood the comparator. Just tell me yes if you have understood the comparator. समझ में आ गया comparator? Yes, we always compare. We always think of only two elements. You do not proceed further. Just think of two elements. If they are sorted, you just tell them yes. If they're not sorted, you tell them no. Why we do like this? Because internally the sorting always works while comparing couple of elements. So you always tell them, give me a couple of elements. If they are sorted, I tell you yes, they are sorted. Or else I'll tell they are not sorted. So internally they swap if they are not sorted. That is how the algorithm internally works. So you don't get into that. Just keep it simple. Whenever you write a comparator, always think it as of two elements. If they're correctly sorted, you tell yes. If they're not correctly sorted, you tell no. Let's for an example, take a vector. Take an array which is storing pairs, okay, which is storing pairs. So pair of int comma int of array is something like this, okay. Let's keep this, and I'll tell you that this is an array 1 comma 4 and 5 comma 2 and 6 comma 9, okay. I want you to sort I'll have to keep moderators from the next day so that I can block, because some people are not liking this, that I'm taking a live class and I'm getting so much of audience. I understand that, but yeah, ठीक है, कोई बात नहीं. You can keep spamming, you can keep on pressing the dislike. I'll still keep on teaching. ठीक है. Yeah, I'll have to make mods. The problem is यार office hours सबके खत्म हो जाते हैं, समझ रहे हो. I'll ask to make mod. ठीक है. हाँ, ignore करो, शुरू करते हैं. Ignore. So I'll take a pair of entire. ठीक है. I want to sort this in such a way that the element who have first, इधर दो elements है, देखो pair है, who have the first element in pair smaller appears first, right? And for an example, यहाँ पे ले लेते हैं. And if first is equal, then sort according to second, and keep the small larger second. I'll tell you इसका मतलब क्या. So if I tell you this is an array 1 comma 4, this is an element, 5 comma 2 is an element, 5 comma 9 is an element. So first sort them according to the first element. So 1 comma 4 will come at the first, then 5 and 5, the first elements are equal. If the first elements are equal, I want you to keep 5 comma 9 and 5 comma 2. Got it? If sorted according to the first, if the first elements are equal, then sorted according to the second, but in reverse. So 5 comma 9 will appear, then 5 comma 2 will appear. Is the question clear? Is that clear? Is this clear? Is this clear? Is it clear? इसको इग्नोर करो, इसको बोलने तो जाने दो, बकने दो, इसको भावी मत दो. Let him buck. Let him keep doing whatever he wants. आप लोग बता दो, क्लियर है? ठीक है, क्लियर हो गया? Perfect. So कैसे करोगे? Has everyone got the question? Right? So I want you to sort them according to the first element in smaller, and if they are equal, I want you to sort them in descending according to the second. How will you do that? So again, it's a very simple way of doing. So I want you to this to be this. After sorting, array should be something like this: 1 comma 4 comma 5 comma 9 comma 5 comma 2. I want you to do this. ठीक है, अभी कैसे इसको करोगे? इसको इग्नोर करो यार, भाव क्यों दे रहे हो? इग्नोर करो. So how will you sort this? Very simple. Again, you'll write sort vec.begin, vec.end, and you'll write a comparator. Right? Now, sorry, array मतलब इसको array लिख लो. So how will you write this comparator? Remember, as I said, only take two elements. So what are your elements now? Elements are pairs. Elements are pairs. So I'll just copy this and I'll say pair element 1, pair element 2. Always remember. Now, just think of two elements. Think of two elements. I am like, I have an element 1, I have an element 2, right? So can I say, if elements ones first is smaller than, can I say if elements ones first is smaller than element 2 ka first? So that means element 1 should always be before element 2. Perfect. If element 1's ka first, I have a pair as element 1, this is a pair. I have an element 2, this is a pair. Can I say, if the first of this is smaller than this, then they are already in correct order? Can I say they are already in correct order? Yes, I can. Yes, I can. So that is correct. Right after that, what I'll do is, I will return true. Now, if I move ahead, what will happen? Else, there might be another case. Can I say, if element, agar ye nahi hai, it's not smaller, then what will happen? Can I say it's then equivalent? That's the other case. Can I say then it is equivalent? Perfect. अगर equal है, तब second पे आते हैं. तब we'll come to the second. And now we will say, is element 1 dot second greater than element 2 dot second? That was our case. Then I'll return a true. Can I say, these are the cases? I'll again repeat. I had a element 1, I had a element 2. In this element 1, I had couple of guys, pair in element. So the first case where I can say कि ये बंदे सही जगह पे है, the first place where I can say that these guys are at the correct. Can I say, if this first element 1's first is smaller than element 2 first, can I say they are correctly placed? Element 1 and element 2 are correctly placed. So I'll return a true. What about the other condition? When are they correctly placed? Can I say, if this first is equivalent to this first, which means they're equivalent. Now I will come to the second guy. I know the second guy has to be greater. So can I say, if element 1 का second guy is greater than element 2 का second guy, तब भी तो सही है. ये बराबर हुआ. If this is equal, okay. But this guy is greater than this guy. Hence they're okay. They're still now okay. So can I say these are the couple of conditions when I can say they're okay. Indeed, can I? Have you got it? Yes, you can. Over here you cannot. Have you got it? Right? Over here it will not work. Greater will not work because I'm keeping an exclusive kind of thing. I'm saying first ko chota, second ko bada. It's an exclusive. Greater int, there is a comparator. I'll come to that. But have you got this? Have you got this? I'm very happy that people are getting jealous and people have so much of time to waste. Get jealous, yaar. आप jealous होते रहो. I'll keep improving. Don't worry about that. Anyways, so अगर ये दो केस नहीं है, if these are not the couple of cases, can I say if these are not the couple of case, then तो गलत है, तब तो swap करना है. So I'll return a false. So have you understood how to write? Comparators? So by the way, in this case, so if I just go back, remember, if you want to sort them in descending, you can use a comparator. Or else, like, you have a couple of ways. Use the same comparator. Use the same comparator. Or else, you can also write something like this: array comma array plus n greater int. Now remember, Remember, this greater int only works, if it is, you want to do it in descending order. Greater int comparator is an inbuilt comparator. Greater int is an inbuilt comparator which works only if you want to do this in descending. Got it? सबको समझ में आ गया? Has everyone got this? Comparator आ गया समझ में? Has everyone got the comparators? Has everyone got the comparators? कोडिंग राउंड के लिए वो काफ़ी है, बट आपको थोड़ा सा और भी करना पड़ेगा. अगर उतना कर लोगे, एंड मतलब वो तभी काफ़ी है अगर आपको पहले से प्रोग्रामिंग कर रहे हो. ऐसा नहीं कि सिर्फ उसी को कर लोगे C++ STL सीख के, नहीं, पहले से थोड़ा बहुत आइडिया रहता है, फिर वो कर लोगे तो काफ़ी है. ठीक है. हैज़ एवरीवन गॉट कंपैरेटर्स? सो आज के बाद कभी भी कंपैरेटर आएगा लिख लोगे, कोई भी हो, पेयर ऑफ पेयर्स हो, यू जस्ट टेक 2 एलिमेंट्स एंड यू डिसाइड क्या ये सही जगह पे है कि नहीं. अगर है तो मैं कंपैरेटर लिख दूंगा, अगर नहीं है तो मैं फॉल्स रिटर्न कर दूंगा, जो हमने इस केस पे किया, which we did in this case. If it is true, I'll just return a true. Instead of that, in every other case, I'll return a false. Simple as that. If it's true, I'll just figure out kya true conditions hai, I'll write it, and in every other case, I'll return a false. Again, this can be written in multiple ways. People can write this in multiple ways. The main funda is, for true cases you have to write, and for all other cases you have to return a false. Okay? No, see, Prachi, if you write greater pair of intent, what will happen is, if you write, Prachi is asking, what if I write greater pair of intent? Okay, I'll explain you this. Prachi is saying, what if the array is, in the previous question, when I had said ki, first chota hai to sahi hai, second, when I said ki the first is smaller, the second has to be sorted according to greater. So Prachi, why will that not work? Because greater makes everyone in the descending order, whereas our question was first in ascending, second in descending if first is equal. That was our question, right? If first is in ascending, it is okay. If they're equal, then in the descending. That was our question. But greater will say, if first are equal, first in descending, and if equal, then also in descending. So it will make descending. That's why greater will not work. Got it? Have you got this? Yeah, it's cool, but yeah, I'll not teach that one-liner because everyone is new over here, so they will not understand writing functions in the int main itself, so I'll not go into that. See, once you know these basic things, after that you can explore and learn, right? It's the stuff is you should understand, otherwise that cool line cannot be written, right? Yes, internally it will say that these two are not correct. Internally it will say that your comparator will say these two are not at correct places, so make them swap. And the internal, that intro sort ya kya bolte hain, jo bhi sort hai, it works in that way. If you tell them false, it will swap it. I'll keep on doing for every element, and it does it in n log n. Okay? Perfect. If there is a pair, greater would sort according to the first. Yes, greater would sort according to the first ka descending kar dega. And when descendings are equal, this will also be descending, but I want in the opposite. I want the ascending. If ascending equal, then I want descending. So you have to write comparator. You cannot use greater. Okay? Complexity is n log n. Even if you use comparator, the complexity will be n log n. Okay? If you just write, remember, in this question of pair, instead of a comparator, if you would have just written array comma array plus 3, then what would have happened is, if you write this sorts in ascending according to first. If first is equal, then sorts according to second in ascending. Whenever you write sort, it's always ascending, 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 ascending for all these stuffs. Got it? I'll just finish it off. 5-10 minutes. I'll just finish it off in 5-10 minutes. Okay. So I'll now take doubts. If you have any. If you have any doubts, you can tell me. Okay, by the way, comparators can be used in vectors, in arrays. You can definitely use comparators in any container which is linear. I repeat, which is linear. You cannot use something like a queue. You cannot use comparator in queue. You can sort a vector, you can sort a string, you can sort an array, you can sort these kind of things, but don't expect you to like cannot use in queues, stacks and all these things. ठीक है मैंने 2.5 घंटा पढ़ा है आज. मुझे नहीं लगता कोई STL वीडियो होगा जिसने एल्गोरिदम्स इतने डीप में कवर किया होगा. आई नो देयर विल बी STL वीडियोस, but I can bet you no one would have compared no one would have gone deep into every algorithm. No one would have taught you comparators. No one would have told you about these edge cases that I told you कि index n चला जाएगा. सारे edge cases किसी ने नहीं कवर किया होगा. तो अगर अच्छा लगा, if you loved this session, please make sure give it a thumbs up. And yeah, सारे groups पे इस video आज से if anyone tells you where to learn STL, don't share a short video because short video will only give you shorter idea. Always tell them ki go and watch this entire 5-6 hour session so that your entire STL concept should be clear, because over here edge cases have been told, problem solving have been done, I have printed next permutation, first occurrence, last occurrence, count, जितने भी different kind of problems हो सकता है मैंने किया है. इससे ऊपर आपको problems करने पड़ेंगे. ठीक है, रेडिक्स सॉर्ट पढ़ा दीजिए. सॉर्टिंग में पढ़ाएंगे यार. ठीक है, सॉर्टिंग में पढ़ाएंगे. नेक्स्ट टॉपिक वी विल डू अ कम्युनिटी पोल एंड उधर से पता कर लेंगे. ठीक है, 2D vector. Yes, you can use it to if you want to sort a 2D vector. So see, if you want to sort a 2D vector, for an example, vector int vec n comma vector int n comma 0. Okay, just assume this is your 2D vector. Okay, and again you want to sort it. So what will be your element? Your element will become vector int element 1. The second guy will become vector int element 2. Then again you have to write the comparators according to your vector elements. How you want to sort them, right? You have to write it according to that. It will become very complex. That is why people tend to use pairs. लोग pairs use करते हैं. That is the reason. ठीक है, perfect. Yes, after this I'll ask you to directly start away with practicing problems at code forces, and whenever you require any container, any algorithm, just use it. No need to go and explicitly start solving problems. There's no need of that. Start solving code forces, start solving code chef. You will require vector, you'll require map. Keep on using. No need to go and explicitly solve problems. ठीक है, ठीक है. We compute 1000 lines of code. Yes, and like थोड़ा कमेंट्स लिखा हूँ, बट 1000 लाइन्स मैंने लिखे हैं 3 दिन में. I'll share it with you. सारे शेयर कर देंगे. स्ट्रीम को लाइक कर दो. I'll share this just in case people forget about this. I'll just keep ID1 for you people. Just in case people forget about this, आप यहाँ से कॉपी कर लो. इस ID का लिंक मैं दिखा दे रहा हूँ आपको. Just in case मैं भूल जाता हूँ, अभी के लिए देख सकते हो. ये देख रहे हो, ये कॉपी कर लो. IEJV69. You can just keep it ID1. मुझे नहीं पता आपको दिख रहा है कि नहीं. Is it visible? ID1.com/IEJV. I'll just write it away. You can just take this ID1. This is the link, guys. This is the link. You can just take it off. LEJV69. LEVJ69. ठीक है. अब विजिबल है. अब तो विजिबल है यार. विजिबल अब तो है. डिस्क्रिप्शन में मैं डलवा दूंगा, बट फिलहाल के लिए मैंने डिस्क्रिप्शन पे शायद कल आएगा। नहीं गलत है, डिस्क्रिप्शन वाला गलत है, डिस्क्रिप्शन वाला मत यूज़ करो, डिस्क्रिप्शन वाला गलत है, ठीक है, डिस्क्रिप्शन वाला गलत है। मैं चैट पे डाल देता हूँ फिलहाल के लिए, id1.com/LEJV69। ओके, मैंने चैट पे डाल दिया है, चैट पे डाल दिया है। मैं डिस्क्रिप्शन अपडेट करवा दूंगा, बट एज ऑफ नाउ यू कैन टेक इट फ्रॉम द चैट, ठीक है। What is the right strategy? I'll take just couple of questions before ending up. What is the right strategy? What is this ID one? This is an online ID you can use for coding. This is an online ID you can use for coding. Okay, it's a good one. DP का देखते हैं, बात करते हैं यार, इंसान हूँ, एक बार एक करेंगे, ठीक है। Right strategy is, see, code forces. Please make sure you participate in every code forces contest. And after that, what you do is, after the contest gets over, make sure जो problems नहीं बने, let's say you have done A problem only, okay, make sure you solve B and C, don't solve D as of now. If you're not able to solve A, make sure you solve B and C. Let's say you have solved A, B, also make sure after that make sure you solve C. Let's assume you have solved A, B, C, make sure you solve D and E. So the next two levels you should solve. If you're not able to solve a problem, like if you're able to solve up till some level in a contest, right after the contest make sure you solve right two levels after that, so that in this way you can practice and make sure you participate in every contest. A lot of people are there who think कि पूरा सीखेंगे फिर पार्टिसिपेट करेंगे, ये नहीं करना है, हमेशा वो करना है, ठीक है। अभी चैट में मैंने डाल दिया था, अगर नहीं गया है कोई बात नहीं, यहाँ से अभी देख लो, LEJV69 है, मैं डिस्क्रिप्शन पे कल डलवा दूंगा। This is gone. So guys, thank you for watching, and please make sure you share the stream as much as you can. If you're new to our channel, please make sure you subscribe to it and click on the bell icon. And yeah, इसी के साथ let's wrap up this video. Let's meet again probably tomorrow or day after tomorrow. I'll be taking another session on recursion as per your request. With this, let's wrap this up. Bye bye.